A warm greetings to one and all. In this session, let's learn about types of machine learning. Types of machine learning are categorized into three types, namely supervised learning. It learns based on labeled data. Unsupervised learning. It learns based on unlabeled data. Reinforcement learning. It learns from experience. Let's start with supervised learning in detail. Here, the model is trained under the guidance of a supervisor. The supervisor refers to the labeled data where each input variable X is paired with the correct output variable Y. The model goal is to learn a mapping function, that is, Y is equal to f of x, that captures the relationship between the input and output. The supervisor provides feedback by comparing the model's prediction with the actual labels, helping the model adjust and improve its predictions. This learned function is then used to make accurate predictions on new, that is, unseen data. The picture illustrates the concept of supervised learning. It begins with labeled data, which includes the images of vegetables and their corresponding labels. This labeled data acts as a supervisor by guiding them in the learning process. The data is split into training data set, which the algorithm used to learn the patterns and relationship between the image and their labels. The learned model is then applied to the test data set, where it classifies the new images into categories like carrot, tomato, or bell pepper. Supervised learning can be categorized into two main types based on the nature of the output. The first one is classification. It is quantitative. It predicts the discrete or categorical variables. Applications of classification are email classification, customer segmentation, sentiment analysis, image recognition, and more. The next type is regression. It is quantitative. It predicts continuous variables. Few important applications are stock market prediction, sales forecasting, energy consumption prediction, house rate prediction, and so on. Classification is a type of supervised learning where the goal is to predict a categorical or a discrete variable. Here, the predicted outcome or label falls into one of the several predefined categories or classes. Let's consider an example to classify the email to predefined categories, that is, spam or not spam, based on its contents. Here, the picture illustrates the classification model. So, during the training phase, the model learns the pattern in spam mail content based on the keywords, phrases that are common in spam mail. So, after the training phase, the classification model classifies the new incoming mails as spam or not spam category, that is inbox category, based on the mail content. So hope you're clear on classification. Let's check out the types of classification. First comes binary classification. The goal of binary classification in machine learning is to divide the input data into two mutually exclusive categories. The training data is labeled in a binary format. It can be true or false, positive or negative, 0 or 1, spam or not spam, and etc. Here, the image illustrates a binary classification task where the goal is to determine that the image is dog or not. The ML model has to classify the image based on the binary labels. Here we have two labels where true indicates it is a dog and the label false indicating it is not a dog. Since the given image is classified as dog, the true option is selected and it is being opted here. Next, multi-class classification. The multi-class classification has at least two mutually exclusive class labels. In this classification, the goal is to find to which class a given input belongs. The image represents multi-class classification. Here, there are multiple labels such as elephant, dog, cat, and lion. Since the image represents the dog, it is classified as dog, as shown in the label. This is called multi-class classification. Multiple class labels are given here. From this, machine learning model should select the exact class label based on the input image given. The next type is multi-label classification. For each input image, the user tries to predict 0 or more classes. Since the input image can have several labels, there is no mutual exclusion. Here, the image illustrates multi-label classification. And we have labels namely elephant, cat, dog, and lion. Here, the ML model has to classify elephant, cat, dog, and lion in the given input. The input can have all four animals also, but the ML model has to predict it accordingly. Therefore, the ML model has to classify multiple labels here. Here, the model has correctly classified both dog and cat, and it has been opted in the labels also as shown in the image. A given text may contain multiple themes in various fields like auto tagging in natural language processing, and the number of items in an image can be multiple, which is similar to computer vision. Hope you are clear in types of classification. The next category of supervised learning is regression. Regression is a method for understanding the relationship between independent variable and dependent variable. Outcome can be predicted once the relationship between the independent and dependent variable has been estimated. Let's consider an example here. So given historical weather data in order to predict the temperature for the next day. So it is predicted based on the continuous variables such as temperature, humidity, wind speed, and etc. Main types of regression are simple regression, linear regression, and non-linear regression. The next type of machine learning is unsupervised learning. So in this method, machine learns independently without any external supervision. The machine is provided with a data set that lacks labels, and it must analyze and make sense of data on its own. The objective of unsupervised learning is to organize the input data into meaningful structures, such as identifying new features or grouping similar items based on the patterns. In unsupervised learning, there is no predefined outcome. The machine's task is to discover the valuable insights from the data in which it processes. So, here the image demonstrates the working of unsupervised learning process. So here we have input raw data without labels with the images of vegetables. The ML model is trained with unlabeled data during the training phase. The ML algorithm divides the data objects into groups based on the similarities and differences available between the objects. So after the training phase, the model finds the correct object such as carrot, tomato, and bell pepper based on the similarities and differences of the vegetables which is found during the training phase. Let's check out the categories of unsupervised learning. First comes clustering. It is mainly used to classify the objects into clusters on the basis of similarities. It classifies the object into clusters through checking which data points has less or more similarities. Here, in this image, there are multiple fruits without labels. The ML algorithm forms a cluster based on the similarities and differences of the fruits. Few applications of clustering are customer segmentation, anomaly detection, and so on. Next, dimensionality reduction. It is mainly used to reduce the dimensions or input data variables in a data set to make the process smoother. One best application is financial data analysis. Dimension reduction in financial data analysis simplifies the complex multidimensional data into fewer dimensions to extract the essential information. Finally, association rule. It is used to find the relationship between the variables in a large database. It determines the set of items that occurs together in the dataset. One of the applications is market basket analysis. So, for market basket analysis, it utilizes the association rule mining techniques to identify the key purchasing behavior of the customer in order to improve the sales. The next type of machine learning which we explore is reinforcement learning. It is a type of machine learning method where an intelligent agent interacts with the environment and learns to act within that. The agent continues doing these three things, that is, taking action, change the state, or remain in the same state, and get the feedback. And by doing these actions, it learns and explores the environment. The agent learns that what action leads to positive feedback or reward, and what action leads to negative feedback or penalty. As a positive reward, the agent gets positive point, and as a penalty, it gets a negative point. It is one of a dynamic programming technique where ML model trains the system based on the penalty and reward. Let's consider this image where it depicts the reinforcement learning. So the environment is where the boy plays the ball, and the agent which we have choose here is the dog. First, the dog observes the environment and selects the policy. Here, the dog misses the catch. So, no reward is given to the dog. That is, the boy is not providing the food for the dog. Now, the dog updates the learning policy. Whenever the boy throws the ball, now the dog catches the ball. In order to get the reward, that is, in order to get the food which is required for it. So, hope you are clear in reinforcement learning. Let's check out the difference between types of machine learning models with respect to various aspects. First one is training data. Supervised learning uses labeled training data, whereas unsupervised learning uses unlabeled training data. In reinforcement learning, it uses rewards and punishments. The next aspect is objective. The objective of supervised learning is to predict an output, whereas unsupervised learning is to discover pattern. And in reinforcement learning, learn to make decisions through trial and error. Next aspect is feedback. So here, the feedback refers to the information provided to the model about its performance during the training phase. So in supervised learning, correct output is provided for the training. In unsupervised learning, no explicit feedback is given during the training. Whereas in the case of reinforcement learning, delayed feedback through rewards is being done. The next aspect is types of problem. So here in supervised learning, we have classification and regression. In unsupervised learning, we have clustering and association problems. Next, in reinforcement learning, it is reward-based problems. Let's check out few examples for supervised learning, that is linear regression, SVM, neural networks, and so on. And examples for unsupervised learning is K-means clustering, PCA, autoencoders, and so on. And examples for reinforcement learning is QLEARN, DQ networks, and so on. Hope you are clear in difference between machine learning models. Thank you all.